Right. Yeah. Thanks for the reminder, Martin. I would have forgotten. So again, welcome to the ALTO working group meeting here in a virtual interim meeting. And as I was saying, this is nothing new for us. We've done virtual interims before. Also with Cisco WebEx, we're a little behind schedule now because it took us some time to get the screen sharing working, but everything is working. So welcome. Next slide, BJ. Next slide, please. Yes. So this is the note. Well, I think I don't have to say much about this. These are the general IETF rules, and these also apply for virtual interim meetings. So you are all obliged to note any IPR you might know related to work we discuss here. Everything is public. Everything is available in the public domain and so forth. And Vijay, I cannot see the slides anymore. Something changed.
I'm not sure what happened. All right, let me share it again.
Okay, thank you. So yeah, I think everybody's familiar with this, but just so that you know this, the IETF rules apply. Also, please look in the chat. Martin already, who's our new AD, also posted a link for the blue sheets. So we're having virtual blue sheets. So please sign the blue sheets here. Next slide, please. So yeah, what's our status? Not from a general perspective, not much. We made some progress, but the general status is the same as in the last meetings. We are focusing on finishing the charter items, the working group items, and for those we have set up the agenda, so we're going to discuss those first. And we want to finish the milestones as soon as possible, and we are getting there. So we will discuss it in a minute. And yeah, thanks to our new AD Martin for updating the milestones, so the deadlines of the milestones. They were a little bit outdated, so we updated them. You can have a look at on the website. Next slide. So as I was saying, the agenda has been set up that we discuss the charter or working group items first. And then we have a little bit time left for other new interesting work, which is not covered by the current charter. Any comments on the agenda? Any questions? Anyone want to change the agenda? I guess that's not the case. Oh yeah, I see on the chat. Martin is asking about taking minutes. We should have note takers. So Richard said he could take notes, and while presenting, yeah, I have to pronounce the name right. Kiao is.
Yeah, I'm the second note taker.
Kiao would be second note taker while Richard is presenting, and also Sabine said she would take notes. Is Sabine on the call? I cannot see her. So yeah, we have note takers. But thanks, Martin, for asking. I don't see Sabine on the call though. I have to check.
Who? You mean Sabine?
Yeah.
Let me check.
She's not on the call so far.
Yeah. So, but we have one. We have one note taker for now, and I hope she will join soon.
Okay.
Maybe somebody can send her an email in the back in the meantime.
Send her.
Okay, next slide, please. Yeah, so what's our progress? So the last meeting was in Singapore in November. We had two interim chairs there because Vijay and I both couldn't make it. So thanks again for that. Our general status is we made some progress. So we have a new RFC 8686, which is the cross-domain server discovery document that finally made it. We have two documents finally in the RFC editor queue, which are cost calendar and SSE. So they are, out of our hands, so to speak. And I think it's just editing now, and they will be soon published at RFC as RFCs. And we have the ALTO CDNI request routing document that has passed a working group last call. So we have a presentation on this document, and we can discuss further. But I think this is pretty much done because it passed the working group last call, and it also got feedback from the CDNI working group. So one of the individual reviewers during this working group last call was from CDNI. And we, as I'm a co-author of this, so speaking as author, also we have addressed all the comments. But we can discuss after Jensen presents this document. So basically, we have 3 remaining milestones: path vector, performance metrics, and unified properties. And
Sí, hágalo bien, si no, ahorita. Mucha voy a hacer esto.
Benefit of working at home, huh?
in the back.
Please mute yourself if you're not talking.
So as I was saying, so we have 3 remaining milestones. They are path vector, performance metrics, unified properties. You can see it on this slide. Each of them is very mature. For each of them, we have a new version, and for each of them, we have a presentation today. So this is our main focus: discuss in these documents in detail today. What's missing to get it out of the working group? Are there major issues? Are there minor issues? What's the status? So that's our focus. Next slide, please. So this is for everybody's information. We have an interesting SIGCOMM workshop this year, which is very related to what we're doing in ALTO. Of course, SIGCOMM is a research conference, but I know a lot of people, the people here work also in research as well as in standardization. So there's a workshop on network application integration and co-design, the NAI workshop. I took it here from the website. The scope is contributions to the design principles and real implementations of systems that enable network application co-design. So I think ALTO is even specifically mentioned also in the call for papers. If you want to know more, you can, Richard can say something later on about it maybe, as he is a TPC chair, a co-TPC chair, and you can find a link here, and the submission deadline is very soon, April 30. So if you're interested, please consider submitting to this conference because it's very related to our work here.
Right. So, Jan, can I just like give 1 minute?
Yeah, go ahead.
Very quickly. The deadline is April 30, 6 pages, and I think we're also considering possibility of accepting 2-page abstract. And it's going to be very interesting, really motivated by ALTO work. And for example, we have 2 very interesting keynotes, one by Albert Greenberg, who is from Microsoft Azure team, and Bruce Maggs from used to be Akamai and now at Duke. So we have a quite interesting, highly related workshop. So we really encourage people to submit to this conference, to this workshop. And very likely, by the way, if you worry about traveling, most likely SIGCOMM, even though is on August 14th in New York City, but most likely will be virtual, so therefore might be make attending easier. Okay, back to you, Jan. Sorry about that.
No problem. No, thanks. Those were actually good points. So yeah, please keep this in mind. And next slide. Yeah, so this is what Vijay and I prepared. We also want to thank Martin, our area director. We had a chat with him also in preparation where we discussed the status of the working group. Remember, we really want to wrap up all existing work group items as soon as possible. That's our focus. And any new work will be, a secondary thought for us right now. Of course, we allocated agenda time to this if there's space, but we really want to focus on the charter items. Any other business? Anybody has something I forgot or we forgot or wants to mention something?
All right. Please sign the blue sheets. Martin has put out a URL on the chat, so please make sure you sign those.
Okay. If there are no other comments, I'm also looking at the chat here.
Jan, should we talk about the cube mechanics?
Say again.
Cube mechanics. So if you want to ask a question or comment on a presentation in the chat,
sure,
put a plus Q. If you want to leave the chat, put a minus Q or Q minus, doesn't really matter what. And that's how we can kind of maintain a line if you wish to comment.
Yeah, good. Yeah. I wasn't. That's very good information. I don't think we did it in the past, but for sure that's good. Let's do this right.
I think
that's the norm you've been using for 107 meetings, because the volume is a little higher than usual.
Yeah, no, good.
So I'm going to be monitoring the chat. So if anybody has any question and want to queue up to the virtual mic, just indicate with a plus Q, and I'll try to keep track of who was there first.
Okay.
All right. Given that this is obviously the speaker cannot see the queue, so if I feel the question is urgent, I'll interrupt the speaker. You know, if you can indicate whether you want to interrupt the speaker, that might help me. Otherwise, we can take the questions at the end of the session. If the speaker is also looking at the chat session and you know, wants to say something, so I guess we'll feel it out as we go along. But let's continue. All right, I'm going to queue up CDNI. That's the next one.
I see Jensen, so he's ready to go, I think.
Jensen, the floor is yours.
I think it doesn't have a microphone.
Jensen?
Are you muted?
From what I see, it doesn't look like with a microphone. So
He can use my microphone. We are in the same apartment. Let me grab him just 1 second.
Hello, can you hear me now?
Yes.
Okay. Sorry, maybe my microphone has any issues. So let's get started. So today I just quickly go over the updates from the last IETF meeting. What's changes and it's about the CDI document. So next test. And so after the last IETF meeting, we have put the document to the working group call and received some comments from the ALTO and the CDI working group. So we have 3 revisions iterated after that and addressed all the comments and the major comments. We put the wording and fix some inits and also update the examples to fix some grammar issues in the example and updated the settings and clean up the background section and the security considerations. So you can see the document is already the design is already stable and we already fixed some minor issues. The remaining issues actually it's because it depends on the unified properties and we should have some updates after the unified properties get stable. So I will talk about the for the major updates for the details of the updates you can look at the document. But the next step I will quickly show some updates on the examples and the remaining issues on the interpreted part. Next one. Okay, so in the new examples, this example shows actually shows the server want to change the delivery protocols of the first FCI advertisement object from the HTTP 1.1 to the HTTPS 1.1, and the previous example is wrong because we try to use the JSON merge patch, but the previous the FCI resource, the response includes multiple objects. So the remaining objects will be removed if you use this merge path. So update the example to use the full replacement instead. So let's update the first update and the next one. So another update is shown in the incremental update example for the FCI resource using the ALTO PID footprint. And in the example, because the FCI resource depend on the network map. So the network map may also change. So we change the example to subtract both the FCI resource and the dependent network map resource. So if the network map updated, so the update service can track the update and send the updated dependent network map for the FCI resource. Okay, so next slide. So that's the remaining issues because the section 6 of the current FCI document use the property map to provide mapping from the footprint to the FCI activity. So, but the property map related the IANA registry is not stable now. So we have some discussion. Maybe Sabine after that, Sabine will give some updates about the discussion and how to update this part of the planning. And major part is that the entity property type CDN FCI capabilities is a resource specific, and it can only be associated with the CDN FCI resource. So we should mention this information somewhere in the document. But what about how to update this part? It depends on the update of the unified property document, and also the property map can also be used to query the FCI property of the PID entities that it used. We should mention that the associated resource of the PID domain must be a dependent network map instead of the FCI resource. So that should be updated in the next revision of the document. Okay, so next one. So the planning of the FCI document is that we're trying to update the property map related part after the unified property document is stabilized, and then we can discuss how to move to the next stage. Question?
So is the idea to move CDNI and unified properties together? There's a dependency.
So okay, wait, if I may comment, is that okay? Oh, you're waiting, Jensen.
Of course.
Okay, yeah, I think actually that would be a question to the working group, and FCI by itself is really independent, but given that we want to demonstrate that this will really become a unified property, so therefore introduce this dependency. But that's probably too much a dramatic change, and I think we discussed yesterday. And one possibility, of course, is we don't even depend on unified properties. We just remove that part, but that's probably a large cut. Then if we don't do this large cut, and then we potentially have to really wait until unified property fully stabilized, because otherwise I don't believe CDNI itself can really move on, because there's a big part where there's a section depending on example.
Okay, so that's not a problem. I mean, if it depends on unified properties, then it depends on unified properties. There's a number of drafts that depend on each other and move together as a group. So I don't think we need to lobotomize CDNI if it depends on unified properties. We just move them together. It's just a process question.
Okay, gotcha. So I'll take a note. So I guess the guidance from you is let's really still keep the dependency, right?
Yeah, we'll just move those together if they are dependent on if CDNI is dependent on unified properties. So it's more a process question. I don't think we need to add any work to our queue to take out dependency in CDNI. That's just more work. We'll just move these together.
Yeah.
Wait, I would like to clarify. So when we say there's dependency, does this mean that the actual text of one is going to change based on the other, or just that there's a normative reference that really need to come together in the editor queue?
Okay, do I answer, or are I waiting on the queue? Or maybe Jensen can answer, or Sabine? Okay. Well, my short answer is following. it's more than a reference. And really, there's a section talking about how to use the unified properties even in the text. So therefore, if, for example, suppose unified property changes some text, some syntax, some way to register, and then the FCI need to change as well. So therefore, there's slightly stronger copy than just like a normal reference, or even in well, it's a modern normative reference. It's even like a text.
Okay. I think we're.
Vijay, just quickly, so just to clarify, I'm speaking now as chair, but I'm also a co-author of this document. So I think what Richard is saying is that we have like a classic dependency where we want to publish these RFCs together. So what you said was pretty much the way we should do this. We should, publish, wait till unified properties is done, and then we can publish them together, because then doing the publication, you can directly put the correct RFC number in the CDNI. You can refer to unified properties with the correct RFC number, right?
All right.
Well, I mean, that's going to be taken care of in the editor queue if there's a normative reference. Like if the only issue is that there's a normative reference and we're getting RFC numbers right, then we can submit everything up to the IESG, and it's all going to correct itself. But if we actually have to change the underlying, if the actual text has to change based on how UP evolves, then we have to hold this in a working group until all these design details are worked out.
Yeah, I understand the difference. But I'm not sure how to answer. Maybe Richard, you can answer it. But Richard's answer was clear. We think we need more text changes also in CDNI as unified properties is evolving to the
short answer is there's a risk of text change.
Yeah.
So may or may not, and depends on how drastically we make the changes in unified property. If we don't, it's very, very likely, but there's a chance. Then there's text changes beyond only the reference numbers. So I would probably have to, of course, that's my personal suggestion is we probably wait a little bit and hopefully not too long, because the unified property coming up.
Yeah, I think we need to move ahead because of time. I think there's a good reason to believe that we need to move these together. There might be some issues for the note takers. There might be some issues on more than just an RFC number dependency, but we can sort those out on the list. But for right now, it seems that we want to move these together.
Okay.
So Sabine, I know we are running late, so all the people that are coming now, if you could, hew to the time, that'll be awesome. Sabine, I see you're online, so please go ahead. Sabine?
Hello, sorry, I was muted. I said I will try to rush the presentation. Next slide, please. So yeah, in a nutshell, for those not so familiar, so as you could hear, unified property is quite a important piece in this working group. So in a nutshell, this extends IPv4 and IPv6 endpoints to entities such as IPv4 and 6 entities, but also PIDs and abstracted network elements as described in the path vector draft. And on these entities, properties are conveyed. The unified properties also introduces a new information resource and media type, which is a property map on entities, filter or not. It is used, as you see, by several ALTO services. It can be used as a standalone service for endpoint entity properties. It is also a part of the multi-part path vector cost map server response that conveys properties on the ANEs that are returned. It is also used by CDNI, FCI, as you just saw. So the entity, one thing is the entity property service handles information resource dependent entities and properties. meaning the ID and values of entities and property depend on given information resources. This requires a careful design for resource-dependent entities and properties. This requires an unambiguous mapping of properties to applicable entities. This also requires an unambiguous mapping of entities, properties to applicable information resource, meaning you can't query any entity or any property for any resource. So for these reasons, this work has been a long-lasting design and specification exercise, but we are we are progressively approaching to the convergence. So next slide, please. So the current version that you can see on the status pages is version number 11 that was submitted in March. So in this version, so basically the changes that are on this version will be also revised and enriched. So I won't spend much time on the changes on version 11, but rather focus on version that are ongoing, the version 12 in preparation, that is in progress and will be submitted as soon as possible. So in version 11, you have changes to simplify and clarify. So actually the non-normative text is of key importance because it introduces so many new concepts. So there has been a huge addition work to clarify the terminology in these sections. So in version 11, there was already so that started already in version 11 on section 1, 2, 3 that are non-normative. In section 5, some text was added on inheritance rules for properties in the IPv4 and 6 entity domain. There is a section 6 that was trying to explain from which entity actually you can get given entity domains and given properties. And this will be heavily revised as well. And in version 11, you have a new text relating to draft IETF ALTO path vector. As you know, this works as a bundle with unified properties. So basically, the text is about introducing an example and see how it works in the IRD and in how properties are conveyed within multi-part responses of for path vector coast. So there is no changes in the design, and further explanation and cleanup and clarification are needed before this draft is submitted for working group last call. So I will go now on the new revision that is in progress. Next slide. What is done in this new version in progress is further explanation on section 2 and section 3 that introduce entity domains, entity properties, and also resource dependent entity domain and resource entity properties, because that seems quite complex, but we need to do this because the information resource dependency that we need to take care of. So in section 6, section 6 was about what entities and domain and properties you can request from which resource. Section 4, 5, 8, 9 are normative, and they will be further clarified and harmonized. Section 10 on path related to path vector will have more generic text for the example, and section 12 on IANA also needs revision. So next slide, please. So by the way, how much time do I have left?
Not much.
Okay. Okay. So in version 12, so typically, so I'll just take a bunch of example.
Sabine, you have about 6 minutes left.
Okay, so that's fine. Okay, typically in these non-normative sections that introduce the concepts, we ended up with a clear definition of what is an entity domain type, which is generic and goes to IANA registration, and what is an entity domain name, which is defined in the ALTO server scope and has to be different from the type when the entity domain depends on a given information resource. This is pretty clear now, and the rest of the text should follow and be much easier to understand and read. Same for the entity property type, which is generic and goes to IANA, and entity domain, entity property name, which has to be different because for a given property type, like PID, for example, the value of this property depends on the information resource on which this property was defined. And it also depends on the information resource in which the entity on which you query this property has been defined. So next slide, please. So in the section 3, there has been further addition. So with a text, clarifying text, explaining why this design seems so complex, actually. And so, so there has been text saying that an entity must be owned by exactly one entity domain name, and an entity identifier must point exactly to one entity. So this explains all the resource-dependent design of entity domain names and property names. So on resource-specific entity domain name, there are further explanation and illustration, and especially when an entity is defined with respect to an information resource. So and explain how this entity domain name must associate the relative resource ID and entity domain type. And we're given an example for network map 2, for example, a PID that is only exists within a network map, a given network map. And if you take the same name for a PID in another network map, it can point to a completely different set of endpoints. So next slide, please. Yeah, so this is also a summary of the updates on resource-specific entity properties. And we explain that actually we take the same approach as in the base protocol, where the property name is associated with the ID of the relative information resource. So in the base protocol, you define, for example, the PID property that you query on an endpoint address. You associate the name of this property to the name of the information resource where it was defined. So, and there is also updates that are being done on that key feature that, well, this is this section explains that a client needs to know what property it can query on a given entity domain. And this section points to the sections that are documenting the authorized combination. For example, you can query query a property on an endpoint, an IPv4 entity that is defined in a network map. You can associate network map and entity domain IPv4, but you cannot associate network map with entity domain INE because it doesn't make sense, and the client needs to know this so that, for example, if a server exposes irrelevant combinations such as network map and ANE, the client is able to know that it just should ignore this. So there is no complicated error handling, but all the authorized associations between information resource and entity on one side and information resource on property on the other side have to be documented in the document where these entity domain types are defined and where these property types are defined. So initially, we thought about making an IANA registry for that, but it's too complex.
You have 2 minutes, sorry.
Okay, yeah, I'll be done. And so so we decided that it has to be documented along with the text that introduces these entity domain types and these entity domain names. So next slide, please. Yeah, so this is about also the entity hierarchy and property inheritance rules that applies in some cases where entity domains can be assimilated to a set and defined by the identifier of these sets. This is the case for address blocks. And instead of defining an individual entity properties, you just define a property on this set. And if these sets obey some strict rules of order relation or inclusion, you can even define some inheritance rules, and this allows you to obtain substantial savings in payload. So I will not go over the rest, but so we can go to the next slide. So this is what these updates were really fundamental because this explains the rest of the design. So we can skip the other slide, maybe the next slide. So yeah, the other important change will be about the IANA consideration. And so we will add a new information item explaining why we need to, the client has to be cognizant of the authorized association between information resources and entities and properties. And also we will add a new entry for the property type registry. And in the next slide, I think this will be the end. So thank you.
So we have time for a quick question if anybody has. Also, please do sign the blue sheets. There is the link to the Etherpad on the chat. Only 9 of 25 people have signed up right now. Questions on Sabine's presentation? So speaking as chair, I think given Sabine's summary of the impacts to the previous draft, I think it seems reasonable to move these together as a group. I think there's enough dependencies outside of just an RFC number. At least that's what I think right now. All right, if there's no other questions, then I will invite the authors of performance metric to please queue up while I put the slide on.
Yep. So I'm here. I'll present and Louis will help.
Perfect. Floor is yours.
Yeah. Okay, and I will talk about ALTO performance metrics. And so you can see that here I'm talking about version 10, which has not been updated and uploaded. The old version, IETF 106, was version 8. And then right by the IETF deadline, which is March 20 something, and upload version 9. And in the meantime, we also made a bunch of changes, made several changes in version 10. But we felt that it's not a bad idea to upload a new version. So therefore, I'm talking about upload it as soon as possible, and maybe right after.
我在开会，声音小点是吧？
Maybe someone should mute. Okay, and so here the outline of my talk is I'm going to essentially give the major updates from version 8 to version 10. And the main thing really is systematic refinement of acquisition context, or someone we call cost context. And we'll give a little bit details and refine the details according to the individual performance metrics. And then we did a lot of general text edit, which I will not go to details. And then we do have 1 or 2 remaining issues which we want to be discussed. We feel that we're mostly ready, but we do want to have get last one more round of feedback from the working group. Next slide, please. So the main change is about acquisition context, and really for people who are not familiar with what it is, and that was a major milestone in terms of really make the document ready, and was basically this, I think that's IETF 105, I forgot. And so major decision with people from ALTO working group, IPPM, and so on is ALTO provides guidance and not measurement framework. That's really helpful, even when we're talking about performance metrics, and it's not measurement framework. And also the major insight last time was ALTO provides multiple types of guidance. If you look at over here, and you can see things, for example, like observed values, that's the central measurement results. You can see things like a target value in the middle and lower of the screen. That's a really committed value or SLA. And if you look at the lower part, you can see highlight a monthly network average, which means the guidance can be somehow, for example, using, for example, like weekly or monthly data. So therefore, there's a lot of diversity inside the system. We should capture them. Next slide, please. So really capture this one, and I think the major success, or at least to me, I'm pretty happy so far now, is we really define something called essentially called cost context. Or I think Sabine wants to eventually change it to maybe acquisition context, because there's a separate draft, which is also in the ALTO working group, has some concept called cost context. So therefore, there's a conflict. We'll find out the name either called acquisition context, or so far in the document in version 10, and it's called cost context. So what's cost context? Essentially give guidance, remember. Guidance, different types of guidance, detailed guidance, how do we really provide the guidance? And essentially use cost context. Cost context has 2 members. One is source, cost source, one is parameters. The source essentially is a very simple high-level value and talk about the type. And parameters is to give low-level details, which is optional. If you look at over here, lower left your screen, and the cost context itself is essentially optional. And then on the right-hand side, you can see that there are 2 members, and the parameters really is essential. We think that's really a best compromise to give the details. At the same time, you don't really like slow down the progress and give flexibility for different deployment settings. Next slide, please. Okay. And so basically, and eventually is we finalize with discussion with Luis, with all other people, we finalize 4 types of core sources. And they are, if you look at the text in version 10, nominal, SLA, and import, and estimation. And we made very clear that it's the operator of ALTO server who chooses the category, because which guidance you're providing, and operator makes a decision. We're not going to enforce it. And we do say that if you don't specify what it is, and 4 categories, application must assume it's estimation, because that's probably the most generic, most big one. And cost context would not be used as a key. So basically still is performance and cost metric and mode to serve as a key. So therefore, if you really have multiple metric, for example, latency, and in the same resource, then you're going to have a problem. So therefore, for that case, you must separate them into different information resources in your information directory. So therefore, we have no ambiguity issue. Next slide, please. So here, essentially is we added text to really give description and about 4 types of core sources. Nominal, basically is static configuration value, if you read very quickly. SLA, and essentially is derived from commitment, which document refers to as service level agreement. But we do mention in text that people use other terms. For example, target, committed, we see from all other ones, and so on. And here we do also give a little bit hint about for SLA, maybe recommended that parameters should give a link to the SLA definition. And import, and why import? I think this one really raised by Luis and several other people, and import by Luis is, for example, what if I know explicitly my guidance is derived from my 8571 PGPLS? Then it should be import, make it clear. So whenever possible, we want to give the option for people to give the specific information, same time allow people to be a high-level abstract way. So therefore, if it is import and recommendation is for the parameters, please give the details of which systems you derive the raw data. Estimation is the most generic version. Essentially, it's just the guidance that I computed from my protocols, from my measurement data, but I don't want to really give you all the details because that's the way I compute it privately. It's really out of scope because this is not the purpose of ALTO. So therefore, estimation we clarify a little bit. Next slide, please. So given this one, and now we feel very happy now because if you look at the left-hand side, and is a definition for every performance metric. And we, for used to be version 8, we really have to struggle, talk about, okay, what are the measurement considerations? How do we do the measurement? I think that's so complex, so diverse, so many parameters. And now we've simplified to the right-hand side, which is cost context specification considerations. So we essentially give the guidance about if it's nominal, what you should specify, and if SLA, what you should specify. If import, we give a couple examples and where you can specify where you imported your number, but it's really performance metric specific, for example, and for throughput, and you can talk about there's nominal value. For latency, you probably don't. Estimation, we give a little bit details to talk about how you really compute it and so on. So of course, this one is down for every single performance metric. We're pretty happy about that. Next slide, please. So given this one, of course, we have a lot of other small changes. For example, usage structure, metric name, and so on. I think the suggestion from the review was please follow RFC 7285 format. So therefore, we change from metric name, we call identifier, and we have the descriptions. Now we change to value representation, and we give the details about them and so on. And then, of course, we did adjustment of normative references. And for example, we really want to give a reference about where each performance metric might come from. There are quite a lot of sources here from IETF and quite a different documents define different metrics. We give essentially potential where they come from. Now they are no longer really normative; they become informative. So therefore, we simplified our reference structure a little bit. Next slide, please. So basically, is only remaining issue is how much detail do we give in terms of guidance on specifying the parameters and for different categories. And the current recommendation is typically for nominal is no, except probably for throughput is give the configuration parameter. And SLA and recommendation is please give a link to where this SLA is specified. For import, please specify which protocol you really imply, and for example, BGPLS or IPPM and so on. And estimation is, if possible, give a link. And link will give a description of tag where you describe. This one will be essentially outside of scope. They're optional, but they're most informative. But we do want to talk, get a guidance about how much, which information we want to specify for each category. Next slide, please. And the other one, of course, the naming, but we don't want to change. But we did got one review and said, do you want to be consistent with other people's name? For example, we call one-way delay. Every single thing here is a one-way. And but RFC 8571 calls unidirectional. For example, delay, unidirectional packet loss, and so on. We did not really do that. So therefore, our question is, we want to keep a current name that's short, simple. Unidirectional looks pretty long, but we do want to get feedback from group. And second question number 2 is essentially, I believe that's a really nice review from very early review, I believe, from Martin, and is, for example, should we focus on have very stable metrics, for example, minimal latency, which oftentimes can be stable and so on, and our latency, for example, latency minimal basically is propagation delay, and packet loss probably mostly because not really like a tuning delay, typical minimal delay most likely coming from, for example, essentially the fiber comes from, for example, some like software failures and so on. They're stable. So therefore, essentially, so one way to do is how to handle these type of things. And one way is we introduce more metrics. We call the metric the mean and the max and the percentile and so on to make it stable. Another one is we introduce systematic model, and essentially you have the metric and you really specify what statistics it is, therefore to make it more stable. For example, if you take a mean, basically you remove away the queuing delay most likely, because queuing delay typically doesn't happen when you have a mean. And so therefore, right now, if we go down this path, we basically take the one-way delay and we add one-way delay dash mean and one-way, for example, loss and mean and so on. So therefore, to make it slightly more stable, then we don't really make a structure change. But that's the feedback we want to get from working group. And I believe that's all I'm done. We feel like we're mostly ready, and maybe the single largest change maybe is question 2. And we might need to add 1 or 2, for example, delays, and probably what we'll say. Okay, I'm done. Questions, suggestions, please.
Any feedback on this? Because we might need to move it ahead. Martin, please go ahead.
Richard, thanks for incorporating my my feedback. Just to be clear, I would recommend min and max instead of something like one-way delay, instead of trying to report a mean, which is likely not very stable. So I don't think that's way too many. I don't want to just have a million parameters. I think it's probably a mistake, but that was the actual intent of my feedback. Although if you choose to do it another way, I suppose that's okay. Do we expect RTT? While I understand that in the real world, reverse paths are often different, do we expect RTT to be different than something other than twice the one-way delay in the context of the way we generate these metrics?
Okay, that's an excellent question. And so if you look at all the numbers, one-way delay, hop, packet delay variation, and packet loss, everything throughput actually all one way. And you're right. So basically, one way, we always think that, for example, people should, if you want the other directions and reverse your query endpoints and you switch the source destination, and you will get the sum of delay. But the feedback I believe we got from early review was such a common query that you should really give RTT. For example, I think that the question was, number 1, by the way, would be answer question number 1 would be why RTT can be different from one-way delay is, for example, source to destination. Maybe use a line, and the reply might come from satellite, can come from essentially asymmetry routing. I believe some data was talking about 30% of asymmetry. So therefore, and essentially save route. So answer number 1 is RTT can be essentially different from 2 times of one-way delay of one direction, and it's really a sum. And the 30% I remember from Arvind and many years ago, several years ago, was 30%. And the second one we introduced RTT was a optimization, because oftentimes TCP throughput depends on, for example, if you really want to estimate TCP, essentially is proportional to RTT and instead of one-way delay. So therefore, that's essentially shortcut. And
so Richard, I think I'm going to cut off the discussion here because we need to move ahead.
I need action item. So Martin, what's your action? So keep RTT or clarify why we have RTT?
I mean, it was actually, I mean, if I can see the case for it, I was just, I'm tempted to try to prune this list as much as we can. And if, while RTT is often not twice the one-way delay, if in fact our measurement techniques and our SLAs and stuff are not trying to make them different, then it might have not been worthwhile to have both. But I think it's fine to keep it in there.
Oh, okay. Yeah, because otherwise,
I don't know if you need a ton of text about that either. I think it's fine.
Oh, okay, good. Yeah, otherwise we want it. Okay, great. Thank you.
All right, Richard, if you could just push for this on the list and close any issues you have. I mean, your question 2, I think having, a metric dash stat seems reasonable. Lots of, moments are captured in CSV files using the same stuff. So if you could just, push to finish these open questions, that'll be great on the list.
Okay, got you. So basically, summarize action item is adopt action, because I really don't want to see, I want to see some kind of like structure as delay dash mean. Of course, I think probably Martin, sorry, I really need to clarify. So are you suggesting and instead of calling mean delay, call it one propagation delay? Is that really right?
Well, you have metric. Your template here is metric dash stat.
Yes.
So to me, what that is implying is that you have a certain metric you're interested in, and the stats are the moments of that metric.
Right.
So, you might have metric dash min, metric dot max, metric dot mean, metric dot RTP, et cetera, et cetera.
Okay, so good. So I allow essentially this one to be defined systematically. Basically, use a dash. Of course, probably only define a few, but using some kind of umbrella template to define a few of them.
Right, and I'm kind of going through that based on, if you look at lots of these data sets that are released for machine learning training purposes, many of their headers are similarly named, right? Metric dash moment of some sort. So let's just go with that unless somebody has specific objections to it.
Great. Any objection? If not, I'm going, because this is slightly larger change than the unstable change. So larger in terms of content.
Again, we don't have to decide that here. We can take it to the list.
Okay.
You like to move ahead, if you don't mind. If there's no other questions, then I will queue up the next one, which is going to be path vector. So Richard, it's you itself again.
Path vector,
actually, it's me. Yep. Sorry, Vijay.
No problem. Let me queue it up.
Okay, thanks. Right. So hi everyone. Today I'm Kai, and today I'm going to present the progress on the path vector draft. So as you may see that we listed 2 versions of the draft. So the version 10 is already submitted to the data tracker, and we also made some changes and to be published after the meeting. And next page, please. So here is a summary of these 2 submissions. So the most significant change is in the early sections, basically in the abstract, introduction, and motivation parts. And we want to revise the early parts to clarify that basically 2 issues. The first issue is that the extension provides information, basically to clarify what information we're trying to provide with this intention, and also according to some comments from the minutes that we want to defend that this extension is not limited to a given application, but can be applied to multiple use cases. And we also have some minor modifications according to some issues raised in the early discussions. And so here is a summary. And next page, please. So the first issue we want to clarify is the goal of extension. And in version, oh sorry, there's a spelling error. So in version 9, we use the term path correlations as information conveyed in path vector, which limits the scope of the extension and gives the wrong impression that extension is only for a specific type of applications. And starting from version 10, we actually use a more general term of abstract intermediate network parts traversed by a path between a source and destination pair. And we think this definition better clarifies the scope of the extension, and also makes the concept of ANE more intuitive. And in version 11, we actually use component instead of parts, so to be more consistent with terms. And next page, please. And the second issue we fixed is the motivation of the document. And in version 9, we use 3 use cases, but do not explicitly summarize requirements. So a lot of feedback says that this makes it difficult to grasp the main idea of this motivation part. So in version 10, we, according to the suggestion of Sabine, we bring back the flow scheduling example, but the current in the current document, the requirements are still too specific to the flow scheduling problem. So in the next version, we are going to use more general additional requirements, which is derived from the flow scheduling example, but can be a lot more generic and can be applied to other applications. So next page, please. And below are some minor changes according to the technical part of this document. And the first issue is to handle cost constraint. And in the early versions, mostly in version 9 and version 10, we had a paragraph saying that how to handle cost constraints in path vector document. And as we noticed that the same problem is raised to the main list on the cost calendar extension. So we also make this explicit in the path vector document, saying that at least for the moment in the document we do not support constraint on the path vector response. And this is going to be included in the next revision. Next page, please. And second issue is we start to change the name of ANE identifier to ANE name. And this is for two reasons. The first reason is the ANE name actually conveys more information than ANE identifier. So when we use ANE identifier, it's most derived from, because ANE is also an entity domain type. So ANE identifier is also the entity identifier of the ANE. And this gives more hints that ANE is an entity domain type. And but also the meaning of the ANE is an aggregation of network components. So it is actually very similar to the PID. So and because PID uses PID name, and we think that ANE name would give a better link to the actual meaning of the ANE. And also in the text, so previously we are using some explicit definitions of basically how the ANE identifier should be specified. And in the latest document, we actually refer to because ANE name must be compatible with the entity ID. So we actually directly use the format of the entity identifier defined in the unified property document. And next page, please. So next issue is also we change so we used to have a property called we used to have a field called ANE properties, which indicates the properties to be queried in the path vector request. And we also change the term to ANE property name because because property name is also consistent with the entity property name in the unified property document. So next page, please. And also we noticed some bug in the specification of the multi-part response. So previously we, according to the RFC, sorry, I don't quite remember the number, but according to the multi-part response document, there's a parameter called start, which indicates the first, which indicates the root object of the multi-part response. But in the specification of the two parts, we actually use the first and the second, which implies the order of the part in the path vector response. So in the latest revision, we actually use path vector part and the unified property map part to refer to the different parts. So the order of these two parts can be interchanged. And the root, and we also specified that the start parameter must either be omitted, which indicates that the path vector part is the first part in the multi-part response, and also when it explicitly specified, it must point to the path vector part. So next page, please. We also have fixed some compatible issues with the unified property document. So mostly, for example, the ANI registry for property entity property types, and previously we have the prefix of ANE, and in the document of unified properties, this prefix has been removed. So we also removed this prefix in the latest revision. So next page, please. Yep, that's all for the update of path vector. And for the next steps, I think as path vector is moving along with unified property as a bundle, so we are also waiting for some final updates on the unified properties. And after that, I think we can talk talk about moving to the next stage. That's all.
We have a minute. Questions? Okay. So this also, in a sense, has a dependency on unified properties. All right.
Yep.
But beyond that, the author team feels that it's baked as much as we can right now in the working group for us to issue working group last call.
Yep, I think the most dependent part on the unified property would be the IANA registries. I think when that is finalized in the unified property, I think the path vector document is mostly ready.
Okay. Okay. So I'm just taking some notes down. All right, great, thanks. If there's no questions, then we can go to the rest of the talks, which are on non-chartered items, starting with Danny's talk. So Danny, if you want to queue yourself up, I'll put your slides up in a second.
So Vijay, can I just give a very quick comment about working out unified properties and path vector and CDNI? Is a bunch of us, we are having weekly meetings. So I do want to advertise, I think we should post on the meetings that given that, CDNI, unified property, and path vector are coupled in such a way that I think early on we thought essentially extracting out unified property as a module is very, very helpful, but it turns out slow down things because essentially need to really become a cross dependency. So I do want to say, if other people are interested and have expertise designing things and can join the meeting on every Wednesday, I believe is from 9:30 to 10:30 US East Coast time. I think would be very helpful, and then we probably can move things faster if we can get. I think typically we have around 8 to 9 people per week, right? So if other people can join, I think it'd be really, really helpful with all the essentially co-authors and people with insights and interest in these 3 documents.
Yeah, I think we need to really move these work pieces ahead. And if unified property is the common factor among all of them, and you guys discuss this in your Wednesday meetings, then for the rest of the folks on the working list, please do participate, because at least from the chair's perspective, we'd like to have the authors of unified property close down any open issues and move it ahead, since we have at least 2 drafts right now, depending on it.
Correct. I can second that. And one other thing, since we are lacking behind time, I would ask the authors that are presenting now to each maybe only use like 80% of their allocated time, so that we can make all the presentations happen, if possible.
All right, Danny, the floor is yours. And as Jan said, please see if you can skip time, get us some time here and there.
Yeah, I think Danny is muted, maybe. Danny?
Danny?
Looks like he's muted. Hey, Danny, I think you're muted.
Okay, in that case, I'll go ahead and go to movie, and Danny can maybe come back. So give me a second. Let me load movie until then.
Hello, can you hear me?
Yes.
Okay, I will present the movie.
Hold on, is this Danny or is this author for movie?
Order for movie.
Okay, let me load your slides then, 1 second. All right, go for it.
Sucks. Malaysian translation. Yeah, next slide. There's a lot of new application for the 5G area. For example, now in this coronavirus disease, we use a lot of cloud-based application like cloud office, cloud education for the students, and the cloud meeting now we are using. And this is a 4K, 8K meeting, and the VRC are emerged. Next. We all know this. For this application, good quality of experience is very important for our for the customer and for the user. And one of the key points for get good quality of experience is get the bit rate or available bandwidth of a network. In such case, we need this application to get to know the network status and the bandwidth. Next. But a lot of applications now assume the network as a black box, and continualism use some private or special measurement to detect the network characteristics, and then adaptively change the parameter. For example, the coding, the decoding, and also change the logic function. For example, sometimes they even close the video part to only support the voice part of the application. So this mechanism has some drawbacks. It's not always precise and not real time. Sometimes, well, not a good user experience. And to solve this problem, a lot of standard organizations, for example, in 3PP standard, they define 4G, 3G, 5G. They have proposed a lot of new, lot of technology to help the application to provide this information to the application. For example, they use they define EC define IETF, but they also have been defined in CPP to help the MS application to dynamically change the bit rate. Also, the 5G, you can see in the right side, they have the defined network exposure function and the platform. Also, in the 4G system, they define the service capability exposure function and the platform. Also, they also have defined in the 5G, defined the QoS notification control. It means that if something for the QoS cannot provide the ground bit rate, they will notify the application and ask the application to some changes. Also, in the 5G, they provide the alternative QoS control. It means that if the current QoS cannot ensure they provide a downgrade QoS parameter to the application, then the application can adapt this bit rate along with alternative QoS parameters. Also, the 5G system are provided QoS stampability to ask to provide information to the application how long this QoS parameter can sustain. After the time, they can change the codec or the logic function. Next. Next slide. So in our paper, we try to use the movie information exposure to help the application to some changes. We now we also do a lot of testing. We based on the 5G real network in our labs, and we use the cell level information, the user level information. We use the AI technology to change this information to the network view. And based on the network view, we take some action to change the reading of interesting and adapt the bit rate. In such case, we can provide a good quality and almost any network circumstance. We use the two technologies. One's the reading of interesting, means that we adapted the encoding on the user-focused area based on the network bandwidth. Also, we use the cloud gaming in our company to investigate this sort of reading of interest. We also use the adaptive bitrate. I think this is widely used technology in current video and gaming application. We use the AI to learn the level capability and adaptively change the bitrate for the application. In such case, you follow the available network bandwidth. Next slide. For the reading of interesting, one of the key points is to find out the Fourier reading of the visual attention. Then we are coding the interest in the reading with high bit rate. Then make the other area with the low bit rate. In such case, the whole bit rate of the video is reduced, but the QE is does not behind. We can show on the right side where the figure will identify the region of the character of the gaming and give more encoding to these characters. So in such case, we need to detect the different region and encoding, select a different encoding. But this technology will introduce some latency. We needed to adaptively change these schemes based on the network status. In such case, we provide good quality and do not introduce the rebuffering. Next slide. We do some experiment with this network enclosure. We use the full ROI thought in 3 different networks. The first one is the original video. The second case is the use very quick signal detection and encoding with just a 10 millisecond delay introduced. And the third case that we use more acute signal detection and high bitrate encoding. In such cases, we will introduce 40 to 70 delays. In the fourth cases, we use the ROI detection with the network information health. In such cases, we use adaptive signal detection and encoding. So now you see these 4 technologies in the 3 different network. One is the network with some low bit rate and some high flag rate. The second is with a network with high bit rates and then low flag rate. And network 3 is flag rated geometrically. Now we have some testing on the table in the right side. So with this table, we found in the column 4 in the row 4 that we have the ROI detection with network exposure can have very good results. We can have a good balance between the detection delay and the detection accuracy. Next slide.
I'm wondering if you can start wrapping it up, if you can get a couple minutes or so from the slides, from the talks, that'll help us finish on time.
Okay, so AMBR, I think a lot of people will know this technology is widely used in Dash. Or also we use AI technology to change the bit rate, dynamically. Next. Next. In this adaptive bit rate change, we use the information for the user level and the cell level. We also use some texting here that we only use the MCS and PRB and can provide a good results. Next.
Martin, go ahead from the queue.
Well, I was happy to wait to the end.
Okay.
We propose that movie architecture for the network application, aware application. In this, we will use this in the network application in the server side, because in current times, in the 3PP side, the wireless network only provide the information to the server side. Now they are not efficiently to provide this information to the client side. Next.
Okay, so if you can wrap it up in a minute, that would be awesome.
Okay. So we propose that extend the ALTO with the movie. Next. And we need to also need something. We need to how to select the network information, how to bind this information with the path of the communication, and how to do the network coding to support the SSE and based on the JSON, and how to support the scalability and reliability. I think that's all.
Martin, go ahead, please.
Yeah, thanks for submitting this draft. It's interesting work, and I actually learned a lot about a lot of things. That said, I feel like it's a little, the draft is a little focused, and the presentation is a little bit overemphasizing the application and what it does with the data for what ALTO is interested in, which is what data do you need. And I am curious if, rather than getting into the weeds of what the exact modulation schemes are and so on, if you can just use a lot of the tools that we're already building in ALTO, like min-max bandwidth, to allow the application to make its decisions. I'm a little skeptical of real-time updates to network parameters going out to the server. It seems like a lot of load on an ALTO server. And it seems like it would have more latency than just direct measurement, which is something you dismissed in your first slide. So it's a bunch of different questions there. One is min-max using the existing parameters. The second one is how much change is there really, or how dynamic do you need these reports to be?
Okay. I think that this movie's extension to ALTO is some different with the traditional ALTO work. Traditional ALTO work is just to select endpoint to communicate, to save the transport resources. So it's like selecting the path. In our paper, we want to say that after path is selected, we also need to get the information on the path and help the application to do the communication. So traditional ALTO is to select the path to provide good quality of service. But our movie is that after you select a path, you also need to dynamically monitor the path to provide the quality of the experience. Is the big difference. The second is, as you say that, yes, this network information exposure maybe provide some additional traffic to the server. our understanding is well dependent how such a network you want it. You want to collect it on network. By different network information you collect it from the network.
Okay, I see there's two questions from Ingvar and Richard. I'm, really thinking we need to close the line here after Martin. What I think what's the best thing to do to move expeditiously and fairly is to probably, Ingmar and Richard, do you have comments or questions that need answers?
I have a question that I would like to get an answer to.
Richard?
I do want to give a very quick comment and about the.
So let's do this. Richard, please provide your comment, and Ingmar, because this is non-chartered work right now, let's continue going to the other presentation, and maybe if you could kindly post on the list, that might be the most expeditious way to go about this.
Okay, thank you.
Richard, go ahead while I load Danny's talk.
Sure. So Martin, very quick comment. I think your question was using minimum bandwidth and maximum bandwidth and all the other things, is it really good enough or not? And I think that's an excellent question to the authors. I remember reading from their draft, they're talking about parameters, for example, what's the current load? Basically, for example, what's the current number of concurrent users in the current cell phone tower, which clearly is not in the anything like we consider as performance metrics, because it's more like a load level on a station. So that's a quick comment. And I think Martin, you asked question would be then what's the implication and real time and so on. I think probably implication for them, what I read, of course, need to correct me, would be you probably need a very flexible way to export all kinds of performance metrics. The current ALTO way of defining a lot of metrics probably becomes slightly not scalable. And of course, if you talk about pushing information, I remember you're pushing information every 30 seconds or even shorter, right? And then it definitely will have a scalability issue. And so definitely in terms of impact on the ALTO would be, okay, how do we really make the information to be compact? Is really even possible to push information at a level of, you mentioned SSE, but possible to really push information like at very, very quick. For example, probably we don't have experiment. I think actually probably Ingmar probably have much more real life experiments, which I will talk about. And can we really push information at the level of let's see, 10 milliseconds or 100 milliseconds and 1 second, and what where the bound really is? I probably wouldn't need a lot of work. Just I'm trying to even take the comments by Martin to really reflect it.
Okay. All right, thanks. So clearly to the authors, there seems to be enough interest. If you want to continue finessing around the edges on the working group list, that's fair game. Our intent right now is at least till the Madrid IETF to finish the 3 open drafts. So please continue discussion on the list. And Danny, please go ahead.
Can you hear me now?
Yes.
Oh, okay, finally. Okay, I will try to summarize my presentation. Next, please.
If you can get us a few minutes, please do so.
Sí. Next, please. So for multi-domain supporting, for ALTO supporting multi-domain use cases, we need to solve the following key questions. What information the multi-domain application needs? What are the issues of gathering that information, and how to design a whole framework? So basically, this presentation will provide some insights to answer questions. Next, please. So let's start with a motivating use case example. Next, please. So here we have the.
Sebastian, do you have a question on Danny's comment or previous one?
No, actually on the current presentation. For the previous slide, I would add to the question, what is the definition of multi-domain?
Yeah,
because even the original use case of optimizing BitTorrent in the access networks of Comcast and AT&T was, so to say, multi-domain.
Yeah,
so I'm missing that from the draft as well.
Yeah, let me try to clarify that. And in our case, please could you go back to the second slide, please? So for this multi-domain approach, Basically, multi-domain involves multiple networks managed by different administrative domains, as I just mentioned in the last.
Yeah, but
the last part of the
Comcast and AT&T are also different administrative environments when we optimized BitTorrent using a tracker from Pirate Bay or whatnot. So even then we had like multiple domains. So what's new here?
No, yeah, the idea is to go more beyond to ALTO to support multi-domain approach, because the current ALTO design is going to provide information in a single domain environment, you know.
So perhaps we let Danny go ahead, and maybe that distinction will become clear as he talks about it.
Okay. So for example, here we have a collaborative network composed of 3 member domain, an application web to reserve bandwidth, for example, for 2 flows. And before the application made resource allocation decision to execute the flows, 2 questions. The first one, what is the end-to-end cost across multiple domains, for example? The cost in terms of, for example, resource availability and sharing. And the second one is the application need to find the sequence of domain and candidate paths. Okay. Next, please. We can skip this slide. Okay, now we identify a very simple information that the application need now. We need to identify key issues in the current ALTO design or for gathering multi-domain network information. For example, in multi-domain scenarios, it's not possible to optimize the traffic with only local available information. That is, the server to client ALTO communication is not enough. So an ALTO or an multi-domain ALTO server communication is necessary to allow the changing network information from multiple domains. Next, please.
Ingmar has a question. Ingmar, please go ahead.
I can wait until the end. Just finish the presentation.
Okay, thanks.
So in order to find available network resources between different source and destination pair, ALTO need to discover which domain are involved for the different traffic flows, and also need to discover a set of candidate paths to know how to reach a remote destination, for example. Next, please. Once the multi-domain connectivity discovery is performed, an application also needs to be aware about the location of different ALTO servers. So in multi-domain scenarios, ALTO server will be located in different network domains. So multi-domain ALTO server discovery mechanisms are also necessary. Next, please. Another challenge for exposing multi-domain network information is that each domain may have its own representation of the same network. For example, suppose that the path cost for domain B is utilization shares instead of available bandwidth. So in this case, both properties are not comparable together. Or even if all domains have the same utilization share property, not necessarily they have the same form of billing, because each domain is autonomous. Domain A may share in dollars, domain B in euros, etc. Next, please. Application also needs a query to express all common resource requirements to the network. For example, for a specific flow, may can provide a set of applications requirements such as reachability, bidirectional symmetry, quality of service metrics, and so on. So the current ALTO provides a very simple ALTO resource query, such as the filtered network map, filtered code map. However, a more flexible query language is necessary. Next, please. There are other issues related to the scalability, to solving the optimization problems specified by the application requirement that can be expensive, uptime consuming, or related to the privacy, because new ALTO extension require fine-grained information. So ALTO extension could raise new security and privacy concerns. Next, please. Finally, we have some mechanisms that could be considered when designing a multi-domain ALTO framework. Next, please. For example, ALTO requires not only server-to-client communication, but also communication from different ALTO servers. Could be considered hierarchical or mesh deployment with a central ALTO server or multiple independent servers gathering information from other connected domains. Next, please. multi-domain mechanism combining domain sequence computation or path computation need to be also defined, or standardized protocols, computation protocol may be considered as well, BGP based on BGP, BGPLS, and others based on the PCE architecture. Next, please. For the multi-domain.
So if you can wrap it up in the next minute, that'll be awesome. Then we have a question from Ingmar.
Yeah, sure. Yeah, the same for the multi-domain ALTO service discovery. There is even a recently ALTO RFC for cross-domain service discovery, but other mechanisms based on PCE or BGP could be also considered. Next, please. The same for multi-domain composition is necessary in order to get all the network information from different ALTO servers to a single and virtual domain abstraction. And also we have a flexible query language to ALTO are able to filter a large number of qualified domains. Next, please. Others are related to the scalability. We need to mechanisms to improve the scalability and performance. We need mechanisms to provide accurate network information and at the same time protect each member domain. Next, that's it. Next, please, we will continue our discussion about the extensions to address the key issues or the deployment concept of ALTO for multi-domain.
All right, thanks for finishing a couple minutes early. So Ingmar, you go ahead and ask your question, and Sebastian, if your question was not answered, maybe you can come back and see.
Yeah, sorry. I don't really want to ask a question so much as to make you aware of the fact that we are already working on this. So we have multiple networks that have neighboring ALTO servers. Currently, we're not exchanging information through ALTO between them. But we are in the process of setting this up and actually building that system. So if you want to get some more deeper insights, or you want to just discuss on how this works in technical terms and what we've already done, we're open for discussion and for question regarding that. And that's when I say we, I mean me and Hans here in the meeting.
Good.
Okay, thank you so much.
You'll be going after the next presentation. So Sebastian, really quick, please go ahead.
So that's really interesting work. I think a subset of what you are trying to solve has already been addressed in RFC 8686. So what we called cross-domain server discovery aims at parts of what you are trying to do. So just saying, I'm interested in maybe discussing what's the gap to what you are trying to achieve and what's missing in between. Thanks.
Thanks.
All right. So again, some interest from the working group. So continue scrolling around the edges of the draft as we get towards Madrid. And that said, Jensen, you want to come back for BGPLS?
Yeah, sure. How many minutes I have?
And again, if you can finish up a couple minutes early, that'll be awesome.
So we only have 16, 17 minutes time left and 4 presentations, so maybe try to make it really quick.
Okay, sure. I think I'll be very quick. And so that's so far that's work about we're trying to leverage the BGPRS to deploy the ALTO services. And when consider the ALTO services, there's some basic ALTO map services like the network map and the cost map, and all of them need some network information, and ALTO had to convert this information to the ALTO map services and the resources provided to the application. And so for the network map, we need the topology information, and it includes the interdomain topology and the intradomain topology, and also the CIDR distributions. So you can discover this information from the topology information and the cost map. So you need the routing information and the performance metrics information, so that you can get the internal routes and the routing cost. And I think let's consider about the BGPRS because it's a potential approach to have all of this information topology. So I'll discuss how to do it and next slide. So the BGPRS actually allows a BGP speaker to advertise a link state database of the traffic engineering database of its connected IGP area. And you can see the benefit is that it's kind of the unified interface to advertise the IGP topology routing information in the IGP domain and the additional performance metrics. And it will use the existing BGP session. So you want to, if you're trying to collect all this data source, so you don't have to establish the extra connections. But the limitation that the only one hop advertisement can be done by the BGPRS. So you cannot, so the BGPRS advertisement cannot be propagated to the remote routing servers. And so next page. So if you're trying to make the ALTO start talking about talk to the every single BGP routers, I think it's very efficient. So we have some efficiency requirements on deploying ALTO using the BGPRS. So consider the other server should only communicate with the necessary BGP speakers, and the other server should only enable the BGPRS advertisement on the necessary BGP sessions between the BGP speakers. So we have some minimization, so minimal consideration. So next page. Yeah. So this page shows when trying to use the BGPRS to collect the IDP topology information. So we'll consider how to do that to minimize the connections to the BGP speakers. So we select, we now select the minimal set of the ASs as anchors, and make sure that each AS can establish BGPRS sessions with at least one anchor. So we found these anchors, and then we make the ALTO server. Each anchor mirrors the received BGPRS advertisement to the ALTO server, so that the ALTO server can cover all the IGP information from the whole network, from the every IGP domains. And because in settings we assume the interdomain topology is relatively stable, because we assume all the ASs come from the single ASP, so you can control all the ASs and know how to what's the peering configuration between the ASs. So next page, it's about some consideration about the routing information collection. And one observation is that we think the route from the downstream ASs can be inferred by the route from the upstream AS. So idea is that we set the minimal set of the ASs as anchors, and so we still try to find the minimal set of anchors, and make sure each AS is provider of the remote provider of at least one anchors, so that then we make each anchor mirrors its BGP read with the ALTO servers, and then the ALTO server can only fetch the routing information from the minimal set of the anchors, but it can infer all the routing informations. So it's necessary to compute the cost map. So next page. Just a quick summary is about the BGPRS can be used to provide the necessary information, but when trying to consider how to collect the necessary information by establishing minimal BGP sessions, so get the process more efficient.
Okay. Thanks.
I have a question.
So Ingmar, why don't you go ahead and ask a question while I load your slides, because you'll be going next.
Okay. Actually, Hans will be presenting. I'm just here to annoy people with questions. So have you thought about all the considerations of the different implementations that especially IGP brings when you're trying to calculate cost maps, and just having the cost map calculated based on a topology does not actually tell you anything about flows or how flows are going to be mapped. Hans is going to touch on that in the next one. Long story short, we have been dealing with this problem for about 3 to 5 years now, and there is a whole lot of can of worms that you're going to open with this one. If you want to discuss this in more detail, again, I can only offer that we reach out, that you reach out. We're very open to discussing this, but there is a whole lot of stuff when you're trying to integrate IGP and especially traffic mapping flows, mapping traffic flows that you're probably not aware of yet.
Good comments. Actually, so far we only consider the OSPF and the SS in the IGP domain, but you're right, there are some many
in the end, what you need to do is map traffic, not topology, and mapping traffic to topology is going to be hard.
So I think we need to take this on the list. I think this is interesting because Jensen's talk and your talk are essentially now trying to trying to figure out how to create these maps automatically.
We're already doing that.
Yeah, I know people are doing that, but to what extent there are, the efficacy of those, the problems of those. That said, it's interesting from the evolution of ALTO, where things are trying to head out now. Before it used to be that the service provider would create these maps, and now there's Strax looking into how to create these maps. About maybe 5-6 years ago, I did some work in using the broadband information across the US that was being captured by FCC to create maps. So this is, and that's published as a paper as well. I can put the information out. So that said, Hans, please continue. And again, if you could get us a couple of minutes, that would be great.
Yeah, I try my very best. Can you hear me? No?
There's lots of jitters, but maybe it'll cure itself as you talk.
Hello, can you hear me?
Yes. Yeah, we can hear you. I can hear you.
Okay, perfect. Okay, yeah, let's start. I tried my very best to be as quick as possible and probably shorten a few slides. Next slide, please. So yeah, the problem statement why we actually do automatic generation is probably well aware. So we have a big complexity, especially in the network we are connected to. We have thousands of routers, but I think it's not, so this is probably a really large scale network. So it also is a problem with smaller networks with probably tens or hundreds of routers as well. Then we have a diversity of customers which actually take or consume these maps. They are different mapping engines. They have different requirements regarding what to optimize. There are different capabilities, actually how they can consume data and what detail level. And the last point of automating network maps and cost maps is basically the actuality. If you automate things, you can be very fast or much faster than doing it in another way. Next slide, please. So as I said, we basically fully automate the processing or pre-processing and pre-generation of network and cost maps. For networks, of course, we need CIDRs for the individual pits, and of course, a grouping criteria, some sort of rule set how to put those pits together. And for the cost map, we need some sort of affinity criteria, basically, which means how to get from one pit to the other. It's symmetric, and actually the data systematic runs on. So basically, what do we need for to calculate and process and automate and generate all this is data, a lot of data. Next slide, please. I think that does not scale very well. The first thing is that we need some sort of the network. So we need the CIDRs and we need the topologies. The topology, not the topologies. There are situations that can have several, but it's not up in the scope. Two sources are already mentioned before. It's IGP for some sort of CIDRs and topology, and BGP, especially for internal and also external CIDRs, which are not from within the network, but from other networks. And yeah, also for topology, the previous call was mentioned the BGPLS, where we can also or might also be able to obtain topology information from. So the problem here is that the data from one router might not be enough, especially if you have multiple peering points, for example. You need the information from at least every peering router. Better is if you get the routing tables from all routers to know how to send data to which destination in this network. Next slide, please. So now we have topology inside us and we can start it. Yeah, unfortunately not. The problem here is we only see our own network. So everything what happens outside of our network is out of our view. And yeah, from an ISP perspective, of course, the most traffic comes from our network. It's video streaming, it's gaming, it's downloads. The problem here is that routing protocol only tells us the forward path. So we know where the traffic flows to, but we cannot actually tell where the source is, where the traffic stream from the source is entering our network. Meaning the entry point cannot be derived from the routing protocol, and that is a crucial part. You cannot tell from the routing protocol where it actually comes from. You need some other mechanism to tell that. The traffic is not, if you don't have full control of all the aspects. So if the traffic comes from outside of your network, you cannot tell for sure where it's actually entering your network. Next slide, please. This is where we use ingress point detection. So ingress point is basically the point where a traffic flow enters your network. So it's a router and if you're more specifically interface on this router where data flows from one source to one destination or to all destinations enter your network. How we do this? So we process actually flow information gathered, for example, via NetFlow or S4 protocol. We collect this information from all border routers of the network. So we can actually see all the traffic that enters the network from the outside, and we're also monitoring some internal routers as well to see traffic flows inside of the network. And then we statistically evaluate those information. And with the statistical evaluation, we find the CIDR, for example, the source, and the route and the interface where it's entering our network. So here we have a small example where there's on the right side, it's on my screen, it's pretty small. We have 4 different streams. The blue, the red, and the green screen are basically from one destination from one source to one destination. And then we have 2 yellow streams, which are basically coming from the same source IP, but depending on the destination, entering the network on different routers and interfaces. So they have, for the same source IP, you can have different ingress points depending on the destination. This is why you theoretically need to do a destination split on your evaluation as well. Practically, I can say we haven't observed such behavior. So usually all the flows from one source entering the network in the same ingress point. And in general, because of the large data, especially you need to process to collect this information and to get to those ingress points, this is a very heavy operation. So we are speaking of gigabits of data every second, just this flow records. Next slide, please. Another way to measure ingress points is actually active measurement, which cannot be performed from inside the network, but must be performed from the content provider. The basic way to do this is, for example, using a trace route and just detect the first router you see within the target network. This is detectable, for example, via the IP. If it's basically from the address space of the ISP, for example, or the host name. It is possible to provide this information before, and it makes it easier. If you have a private peering, you also can just take the counterpart of your own border router. Then you need a channel to get this.
If you could wrap it up now, we're getting close to the top of the hour.
Yeah, this is the last crucial part, actually. So after that, I can run pretty fast. And then you need a peering point, and then you just need a channel into the ALTO server. Sorry, I have a large feedback. Okay, and then you need to channel into the ALTO server. And that is basically when we compiled the slide, we had the idea, why not integrate such information into ALTO map request. Next slide, please. our basic idea was just to integrate information in network across map requests. I know this is a GET request at the moment, so we might need to change it to POST request to insert data. And also from our side, it is not, so we cannot pre-calculate those information anymore and need to be, if we ever want to do this, more cost efficient. So because to speed this up, if this is something somebody thinks is worth pursuing or has an idea where it can be integrated in something existent, I'm happily discuss this with anybody who's interested in. Next slide. So yeah, we need some additional data in the end, so we can skip that one. If you want to have more details on it, feel free to ask me. And yeah, I don't need to describe the summary. Basically, the points are there, and that's it.
All right. I know we are at 9 o'clock right now. We have 2 more slides, 2 more talks to go. Jan, do you want to maybe extend for 5 minutes and have them present their ideas quickly? Okay, so those of you that want to leave, please do, but we'll go about maybe 5 minutes over. Richard, you have a quick question?
Sure. Yeah, and while you're loading my slide, I believe I'm next one. Basically, quick reply to enhanced question about this on-demand measurement, and absolutely, there's very strong interest. We're not from my side. We're actually having by the way, number one, is really impressive work, and number two, answer your question is. There's a lot of their interest, and you post question about on-demand generation map, and a key person actually is Lyle Bertz, and BERTZ, LYLE, and Light, and Lyle, and his and he has I believe I heard from him a couple of times. He said, okay, the only way eventually to handle these issues is to on-demand and using this like a request to trigger the measurement. I don't believe he's online here either. I think Farney also from Sprint. She's not here. I believe there's a conflict, but the short answer is there's a very strong interest about this. I think that's really, I think that's a very interesting direction that which is good direction for pursue.
Perfect. So if we can set something up.
Yeah. Okay. So again, interest in the work. Please go ahead and on the list, and we will figure out how things are moving by Madrid IETF. Richard, please go ahead. Sure.
Okay, and I'll try to finish as soon as possible. So I'll talk about incremental update using HTTP2. Next slide, please. And basically I'll very quickly give an overview of SSE, which is the essential server push, and then why we talk about HTTP2, because actually really the motivation came from the IESG review. Next slide, please. So ALTO SSE turns out to be relatively useful tool and provide 3 goals, functions: push updates, instead of pull and push. Number 2 is when you do the push, don't send the whole information, do a compact incremental encoding. Number 3 is if you want to push information, you should give a client to tell you what information you are really interested in. So therefore, you should do dynamic stream control. And the current ALTO SSE essentially is the design using 2 services. One is update service, you get all the update messages, and then the second one is stream control, and which essentially you specify what you're interested in. So that's architecture. Next slide, please. Why the SS design as it is because it is HTTP 1.x compatible design. And in that, with that essential architecture, 2 services. And what's issue number 1? And is allow dynamic addition and removal of resources. Basically, we call SSE calls substreams to receive data updates. But HTTP 1.x would allow sending only 1 request at a time. And so therefore, if you send a request over there, and for example, look at the client, look at the bottom page, and the client send a request that, okay, I'm interested in this update. And later, if you want to change and set, and you cannot send in request anymore from the same connection. So therefore, you have really started a different connection. That's why it introduced a concept called stream control server. And stream control server will get requests, and then through a private channel, and gives to the update server, and this update server will send the additional or stop of the updates. That's why I end up with the architecture. Next slide, please. The second issue why SSE end up with this architecture is you need to multiplex multiple logical data streams. And because why? And when the client and connects to the server, and then essentially have a control update, tells you which stream stopped and running, and also data updates for different resources. For example, the client subscribes to say 3 network maps, and you need to push for 3 network maps. So therefore, essentially, there are a lot of logical data streams. And they have different media types, and some with full encoding, some with different incremental encoding, and so on. So essentially, it turns out to be complex. So how to really do this multiplexing? And for HTTP 1.x design, and the design was using SSE, and essentially it exists HTTP HTML5 design basically is you send SSE events, and each event would have the media type and data ID. Media type essentially really tells you what really the type is. You can use, for example, you can have a control update, and you can also have data update, and essentially media type tells you what the encoding is. And then you have data ID essentially to do multiplexing to tell what really is multiplexing is. And then of course you send all the data around. Next slide, please.
So really quick, if you can wrap it up and
Okay,
get to the issue. What's the issue here?
Right. So basically, here's a really is single serialization and inter-stream and inter-substream. You serialize it into everything into single update stream. Next slide, please. The main issue. Next slide. Okay. Next slide really is, and basically is, we can actually do better using HTTP2 if, go back one slide, please. And basically really is, I think the push from ICIG is, if we have HTTP2, do we end up with the same design? Can you really gain from benefit of HTTP2? And it turns out HTTP2 can give two benefits, multiple benefits. Number one is multiplexing. And that's essentially using single serialization of all the streams. So therefore, you serialize, you do your own multiplexing, but you still end up with only one data. So therefore, you still can have a essential head of line blocking, and HTTP essentially allow you concurrent updates. And second one, HTTP will allow bidirection. So therefore, you don't really end up with two connections. You might be able to do only one. And of course, more efficiencies, header compressions, flexible controls, priorities, bandwidth allocation, and so on. Next slide, please. So basically, here's an initial design, which I don't need to go to the details. And essentially is we want to potentially leverage HTTP2 design to do multiplexing and have single design and to essentially take advantage of HTTP2 to gain better performance and simpler structure. Next slide, please. So basically, initial draft, we have draft, which I have not uploaded yet. And feedback on the design, probably given the timing, I probably just post on the, I guess, the mailing list. And then, of course, really question to the group is also would be right now, of course, IETF also evolving from 2 to 3 and so on. And do we target 2 or really continue essentially chasing the newer transport layer? And for example, 3 or not. So I will post those questions online.
Great, thank you. I think a lot of this introspection came from, I believe, one of the AD reviews or so. But again, let's take this onto the line online. This brings us to our last talk, which probably keep it to 2.5 to 3 minutes, please. FDN. I don't have any slides for this.
Oh,
this is Zhong from FDN side. Sorry for didn't upload the slides. So can I share my screen or just talk?
You can share your screen, but please do it really fast. I'm trying to find you.
Okay.
Could you tell me your name so I can give you the ball?
This is Zhongxing. ZHONG. XING.
ZHONG.
XING.
Okay, somebody is displaying, so please go ahead. 2 minutes.
Okay, function delivery network. It is our concept of delivering functions to the edge of the network, similar to the CDN that is which is used to deliver contents. We are using FDN to deliver functions to the edge of the network. The architecture is like this. I will go through it really quickly. So we are using a controller-based mechanism to deliver functions to the edge of the network. And by functions, we mean some operational calls or some business logic or even application, some application modules. Because the time is really limited, I will skip the technical details. But the function delivery network is deploying with the China Mobile's and China Telecommunications network in China. And currently it is operational in several provinces of China, and we are integrating the idea of ALTO with FDN to make the function delivery in the edge computing area more efficient and more applicable. And the for the implementation of the FDN, we used IBM OpenWhisk and also Kubernetes to disseminate the Dockers and containers and to optimize the network traffic in the system.
1 minute.
Okay, so that concludes my slide. Thank you.
Cool.
Really short.
You want to give closing comments?
Yes, I can. So thank you everybody for participating. I think this was actually not a bad group. 25 people, I think, participated. So thank you, and thank you for all the presentations. I can remain. So basically, it remains what I said in the beginning, and we want to finish the milestones first. And I think we're on a good path. But I think today's presentations showed that there's still some work to do, and I'm happy to hear that Richard reported that there's going to be weekly meetings to progress this. Vijay and I would like to have this done by summer, whatever the summer meeting is. I guess it's going to be a virtual IETF meeting again. At least personally, I cannot imagine a meeting happening in Madrid in July or whatever. Yeah, so we want to close the milestones by then. And yeah, thanks to everybody. And we continue on the mailing list. I mean, all the questions we had and all the progress of the documents, of course, we're going to continue on the mailing list.
Great. For those of you that haven't signed the blue sheet, please do. The link is on the chat. I'll stop the recording, but we'll be on to let people sign the blue sheets. And see you in Madrid in some form, virtual or physical.
Correct.
Thank you.
Okay, thank you.
Bye.
Thank you, guys. Thanks.
Thank you.
Thank you guys. Bye-bye.
Thank you. Bye-bye.
Bye.